the FTS 5000. It's a linear axis stage. The FTS 5000 has 40 Gs of maximum acceleration, and it can do a 25 G path continuously. So you're able to make your parts much quicker. And that, for a lot of customers, is the main benefit of it. You just be able to make parts quicker. And another advantage of the FTS 5000 is the very linear actuation mechanism and the very linear feedback mechanism. You have a voice coil driven actuator, so it's very linear. For a given amount of current into that gets you a given amount of force out. And then on the feedback mechanism, we use a glass scale encoder feedback. So it really is like a miniature actuator. With the FTS 5000 and it being digital, we are able to remote into the unit, and we can change gain values. We can even take a look at, we can log data at what the customer is cutting and get feedback as to what are the voltages involved, what are the currents involved, how can we maybe tweak the feed rates, the RPMs to create a better part for the customer. All that kind of diagnostics are only available because of the digital capabilities of the FTS 5000.
Zero penalty freeform refers to the FTS 5000's ability to allow the user to machine a complex freeform surface with the same form error and similar cycle time as machining a traditional A-sphere. So in any machining process, the temperature and thus the dimensions of the workpiece, the machine, and the tool are all going to fluctuate based on their own coefficients of thermal expansion. The reason we want to machine things fast is to minimize the effects of temperature fluctuations over time.
More recent applications for freeform optics are for augmented reality or mixed reality goggles, and that's pushing a lot of even crazier freeform shapes. So we focus on surface finish and then normally form accuracy, so figure accuracy, how much peak to valley deviation it is from the ideal. It also comes into infrared optics too. We get performance requirements in terms of waviness. In terms of spatial frequencies on the surface, high spatial frequencies are roughness, low spatial frequencies are form error. Then we get this middle zone, mid-spatial frequencies, a lot of people call it, or waviness. And there's different error sources on a diamond turning machine for all three types of errors. And that's some of what we're focusing on now, and our new fast tool servo technology is particularly well suited to address some of the new waviness specifications.
So we work very closely with our sister companies, Taylor Hobson and Zygo, who are world-class metrology providers. And we also have solutions within Precitech where we do on-tool metrology as well. That allows a customer to be highly confident in the results that they get off of our diamond turning machines.